Hi, Graham Hayes. I work for Microsoft Azure currently. I was the PTL of the OpenStack DESIGNATE, which is the DNS service project, for about 4 or 5 years. And I currently sit on the OpenStack Technical Committee. Contact details are there. There'll be links to the slides further on. If you have any questions later on throughout the event, just use any of these, and I can help evangelize a DESIGNATE even more. So for those of you who aren't familiar with OpenStack, OpenStack is a open source infrastructure as a service solution. So it's made up of a huge amount of smaller discrete components that combine into one full solution. And it has DESIGNATE as just one part of that. So you can see we're over here in the networking section. And because of everything being discrete APIs, all the different components talk to each other over these APIs. So the core design and the core tenets of what OpenStack is that everything should be multi-tenant from the very beginning. It should support having discrete segmented user space, so people can only see what the things they're supposed to see. We have a common authorization and authentication layer, which is also another project within OpenStack, and it has standard interaction. So all of the different OpenStack APIs have the same authorization middleware. OpenStack is a API layer. It generally doesn't implement a full data plane. So, for example, with the compute project, you can choose Zen or KVM, or even Docker or Hyper-V. And the same goes for things like networking, where you can choose the different network providers, so you can use Cisco or whatever. It's also, everything should be highly available from the beginning. Everything should have the ability to work active-active and scale out to allow for increased usage and HA. So for DESIGNATE, this means we have a pretty pluggable architecture. DNS is something that's generally quite custom in a lot of people's deployments. So we allow users to extend what the core functionality is with fairly simple Python extension points. So you can add additional API endpoints. For example, when we had this deployed in HP Cloud, we had to add in a load of billing endpoints. So the internal billing tools could collect usage and the number of records and zones created per user. We support a lot of different DNS servers, and we allow you to modify what notifications are emitted. So within OpenStack, there's a standard scheme for emitting notifications on when things are created, updated, deleted, or when things exist, but we allow you to write your own Python packages to emit what notifications you need. We support anything that has a SQL Alchemy backend, pretty much. There's some problems with Postgres right now, but in general, if your database is supported by SQL Alchemy, we can use that as a database store. We allow you to plug into different quota management, so there's a reference one built into DESIGNATE, but you can use there's about 2 or 3 others available within OpenStack at the moment. And then for policy, there's a reference policy implementation, but you can extend that to be whatever you want. So I know there was some people experimenting with things like Open Policy Agent and some of the other remote policy controls. So the 2 main servers we really support are PowerDNS and Bind. Every single commit gets tested against those 2. We do support info blocks. That's tested semi-regularly. And we also support DESIGNATE as a DESIGNATE server. So, for example, that's used where some people have an internal installer DESIGNATE, but they're also using a cloud provider that runs. We support some of the DNS services, mainly ACME and Dynect. And there is experimental support for some things like the Microsoft DNS server and NSD and NOT. There's a full list at this slide here, at that address. At its core, DESIGNATE covers everything in Designate is scalable outwards. There's no active passive, it's all active active. It all centers around using pretty much all of these interactions are done over a messaging queue, generally RabbitMQ. And as you can scale up. This was designed to run at rack space scale, which was a couple of million zones. And I run my personal one on a ARM box in Scaleway, and it runs fine. Basically what happens, it's an eventually consistent API. So the API will always represent the desired state, but we use the DNS protocol itself to send zone transfers to update the DNS servers. Generally, when you create or update a record, it's done by the API. We have our business logic is done in the Designate Central section. And then it will push out the notification to a set of workers that this zone has been updated. You need to notify the far side of the DNS servers that something's changed. And then we wrote a very small DNS server in Python that can read our database directly, and that's used for sending zone transfers. We also have a producer which is used for recurring tasks, so for making sure that notifies haven't been lost or the zones are out of date, so we send the periodic task to go check everything, all the serials are what we expect and the zone contents are what we expect. And because we support so many different DNS servers, the backends are just pluggable pieces of Python that plug into the worker. So it knows when it gets a zone create event for PowerDNS, it just sends a HTTP request to the PowerDNS API. Whereas with bind, it'll use a RNDC call, or for ACME, it's a different type of API call. We also support multiple pools of DNS servers. So you may have an internal R&D set of servers that are running just in your data center, and then more important central company servers that are run across your network, and then your external DNS is, say, an Akamai or Dynect. Because of this, because of the pluggable system, we reuse the same infrastructure. So when you're creating the zone, you can just create scheduling hints when you're sending the request to help it choose the right zone for the right set of servers for your DNS zone. And it all reuses the same infrastructure, so you don't have to run separate copies of the mini DNS server or the producer or workers per pool. It's just one homogeneous use. The API is the main interaction point for both end users and other DNS components, other OpenStack components. So we have quite a tight integration with the OpenStack networking service, which allows people to set reverse DNS entries for public IP addresses supported by the OpenStack networking, and for users to create DNS names automatically. So you can tag an OpenStack neutron network with a DNS domain, and then when you create any new port on that network and you provide a DNS name, it'll auto-generate the A or quad A records and the pointer records for that IP address. So we're pretty well integrated into the overall OpenStack ecosystem. We have a dashboard plugin. You can use the OpenStack CLI, the standard OpenStack CLI, to do all the interactions with Designate. We don't have separate clients. If you use Heat, which a lot of the telecommunications companies have sort of standardized on for deploying apps, we have resources available in Heat to create and manage DNS zones and records. And as I said, the networking service has the integration to set up forward and reverse DNS for ports as they're created. We also have a separate plugin point, which is called Designate Sync. So this is for sometimes systems don't necessarily have the logic to call out to designate whenever something happens. So this can listen to a queue, an AMQP queue, and as messages come in, act on them. So we have a reference implementation that will just create DNS names for neutron ports, but it's a really powerful extension point. So for example, there's a ISP in the US that every time they created a new tenant, which is a project, like a span of control section in OpenStack, it would pre-create DNS zones and pre-fill the required information into it. There's others who update their records via it for load balancing or for HA. They just spit a message onto the queue, and DNS Sync will pick it up and act on it. So, just as an example, if you want to use use Designate to create a zone, there's a lot of installers. So if a provider for like an ISP or your internal cloud is shipping an installer bundle as a heat template, they can pre-provision all the required DNS entries, and then because this can read values from other resources, if you had an OpenStack server resource, you could start creating the records as needed from the outputs of that. Externally, we're pretty well integrated in Ansible. Again, it's the same as Heat. We have pretty good Terraform support. And then within Kubernetes, the external DNS project supports Designate natively as well. There is a certbot implementation plugin. It works reasonably well. I wrote it and use it, so if there's any problems, shit. Again, I needed to use Let's Encrypt, so it was the easiest thing to do. And we have pretty good SDK support, so there's Python, Java, and Go SDK support. So if you decide you need to re-implement your own logic, it's all there. It's a pretty easy system to program against. It's a very simple API. I have some examples later on you can see. And if we don't have a SDK for your language, shout. I'd be more than willing to help people. So again, this is just an example of an Ansible integration. It's a top-level supported part of the Ansible Cloud extensions. And the same for Terraform. It's a little small, but again, the OpenStack provider for Terraform has the DNS resources you need. So the standard CLI is pretty simple. It's verb-based, so in this case, OpenStack zone list just lists all the zones you have. This is choosing Vexos because this is one of the places I had domains, and creating. I don't know. It's just OpenStack zone create followed by the required information. If you were using multiple pools, you could provide the scheduling hints here as well. And if you wanted to create a secondary zone where we would pull information off of your own DNS server, it'll be added here as well. So this is probably more useful if you look at the slides later, but the API is fairly self-explanatory. Whatever your endpoint is, /zones lists all your zones, for example. And we tried to be as REST-y as possible, so there is links to pretty much everything in each of the objects, which makes it easier if you're programming against it. And then everything is nested, so you have your zone, its ID, followed by record sets, would list all its record sets, or record set / the record set ID will show the precise record that you're interested in. It's just an example of the UI we have. It's fairly simple. Shows you a list, allows you to see what the status is. So as I said before, it's a asynchronous API. So if it knows it hasn't the customer-facing DNS servers haven't been updated correctly, it'll show up here, and the status is, for example, pending, or if there's a problem, there's error. So we allow you to set the pointer records in the UI as well. You don't have to use the CLI or rely on the auto-generated records. And then as you're creating the floating IPs, you can also set reverse DNS. So in short, why should you use Designate? It's a real advantage if you're running a cloud, with the support for allowing all of your users to manage their reverse DNS without having to give them access to the full zone. It makes it much easier. It's having a multi-tenant DNS API. Because it's relatively small and lightweight, and the authorization service Keystone is also quite small and lightweight. If you just need DNS in a multi-tenant way, it's very easy to run, and it allows you to provide a service to all your users. As I said, I run just the Keystone, which is the authorization service, and Designate on a small ARM box. And I haven't had issues. It's been running for a couple of years at this point. Because we support so many DNS servers, and we allow you to manage those servers directly, it means you can reuse existing DNS infrastructure. I know a lot of people have pre-existing sets of servers around the companies, and the thought of trying to recreate everything from scratch can be quite daunting. So in the past, it has allowed people to take their existing infrastructure and allow Designate to manage some of it. So this is the set of list of links. The slides are there as well. Designate, the docs have everything from the install guide for Ubuntu, CentOS, and SUSE Linux. The code is all here for the main service. We are in Freenode, OpenStack DNS. I'm Muggsy in that channel. I'm generally around European times, and are more than willing to help anyone who has issues. We use the standard OpenStack mailing lists, and yeah, the slides. So with that, is there any questions? No?
Does it work with Cola, Ansible?
So the question is, does it work with Cola Ansible? Yes, it does. It's not quite point and click. There is a couple of extra steps you have to do, but I've actually helped a few people install using Cola Ansible, and once we got it up and running, it was great.
Any other questions? Go ahead.
Just a question about OpenStack. You mentioned you worked in Azure. I don't expect you to talk too much about Azure, but I'm just curious, how popular is OpenStack DNS amongst the big cloud providers? Are they borrowing on this technology? Are they using it in the background?
For the OpenStack cloud providers, a lot of them use Designate. Azure doesn't. Obviously, we had our own infrastructure long before I joined Azure. Within all of the cloud providers have their own DNS service that's kind of homegrown over the years. Most of the OpenStack distributions support Designate, and a lot of the public cloud providers have it. So the likes of Vexhost or City Network will all have Designate support.
We have 10 minutes left in this slot. Any other questions? Anything OpenStack? If Graham is willing.
So you automatically can create
Yep. So the question is, does it? We can automatically create A records based off of an instance or a port being created in Nova or Neutron. Does it create PTO records? By default, if you specify the DNS name and DNS domain, yes, it'll create the PTO record automatically. You can provision the floating IP and provide a PTO record later as well, though, if you want. It doesn't have to be automatically provisioned.
Support DNSSEC?
The question is, do we support DNSSEC? Right now, no. It's been a bugbear of mine for a long time. I'm allergic to writing crypto code. So there's been a debate about how to do it. If people have ideas about how we can do it without re-implementing everything and managing and keeping keys in our own database, I'd be delighted to talk, but it's not super high, and it's a lot of work for not necessarily a huge amount of payoff.
We have some Power DNS and Bind developers in the room if you need any. So have you found that supporting multiple name servers makes the coding harder?
Yes.
Limits you? Yeah.
Yeah, so a lot of the, for Bind and Power DNS, it's not that hard because they're both fairly established APIs for creating and managing zones. It got a little harder with some of the things like NOT that required local commands to be run on the DNS server. And Power DNS before the API had, in all honesty, it was awful code we wrote to manage the creation, deletion of zones. But since the API came in, it's a REST call.
It's good to hear. Yes?
Is it possible to set up everything on a single box? Because I see there's a new DNS that contacts the other one.
Yep. So for one of the pools on my personal...
The question was, can you run it all in one box?
Yes. So for one of the pools on my personal setup, there's the entire OpenStack and the DNS server on one box. And it also has other pools that are remotely managed. So yeah, but you can run everything on one, and there's no issue.
Is it useful to run all of OpenStack on one box?
Well, I don't run all of OpenStack. I run Keystone and Designate for my personal install. In general, no, it's not useful to run OpenStack in one box. For testing, yeah. For testing and development, it's great. You're not going to get a lot of value if you install all of OpenStack in one box and expect it to manage and host VMs in a relatively stable manner.
Perl SDKs? Perl SDKs. Are you going to do Perl SDKs?
If somebody who can write Perl is interested, I honestly can't write Perl. So
can you write
won't.
Perl? Okay, you have a volunteer.
Great.
Any other questions for Graham? Thank you, Graham.
Thank you.
Oh yeah, don't need that. You can take a bottle.